All right, guys, welcome back to Algebra 2-8. We're talking about proportions and similar figures. Very important for geometry, very important for algebra, very important for everyday life. I use proportions actually a lot in my own personal life. I do a lot of handy work around the house and whatnot, and I use a lot of proportions. For example, let's say I'm painting, and I say, okay, I'm just throwing out numbers. I use 2 gallons for 685 square feet. I still have 1,800 square feet to paint. How many gallons do I need? That's a proportion. I don't go to Home Depot and say, I guess it's going to be 5 gallons. I don't know, though, because then I'm wasting time and money. So I set up proportions all the time in my own personal life. Similar figures are very, very useful using proportions. It's one of the best uses for proportions. Similar figures are figures that have the same shape, but not necessarily the same side, guys, okay? The symbol, this, it's a little squiggly symbol, okay, this guy right here, means is similar to. Doesn't mean it's equal, it means it's similar. And again, similar means it's the same shape, but different size. Okay, same shape, but different size. So for example, okay, we have triangle ABC, the little similar symbol, and triangle FGH. So this is saying that triangle ABC is similar to FGH. So if it's similar, that means that it is the same shape, but different size. Okay, same shape, but different size. So that is what similar means. Same shape, but different size. Now, there are 2 things about similar figures. Doesn't have to be triangles. Any polygon, even circles can be similar. But when we're talking about polygons, okay, that means that they're made up of straight lines and you have angles, corners called vertices. When you're talking about similar polygons, their corresponding angles will be congruent, and the ratios of their sides will also be equal or congruent. This is what I'm talking about. For triangle ABC being similar to triangle FGH, in order for this to be a true statement, okay, the measures of the corresponding angles are equal. The angles must be equal. Okay, corresponding angles must be equal. And the ratios of their corresponding sides must also be equal. Okay? Now, corresponding angles must be equal, corresponding ratios of the corresponding sides must be equal. Now, when we're looking at corresponding sides or corresponding angles, I want you to understand that I do not want you to find the corresponding angles or sides by the figure. I want you to find the corresponding sides and angles by the actual labeling of the polygons given to you. Okay? In this particular case, they're both straight up, so it's pretty easy to know that A corresponds to F, and B corresponds to G, and H corresponds to C. Okay, that's very easy to determine. Very easy. However, life, unfortunately, is not always that easy. So sometimes they'll take and they'll do this to you, and they'll flip it. And for the untrained eye, for the person who doesn't know what they're doing, they may say, oh, A is congruent to H, B is to F, and C is to G. That's going to be wrong, completely wrong. So do not, I repeat, do not label ever corresponding sides or angles by the figure. Label it by the actual lettering that was given to you. So, for example, you have triangle ABC is similar to FGH. Check it out, guys, because it's So easy, but yet so complicated if you don't pay attention. First letter A corresponds to first letter F. Angle A must be congruent to angle F. We don't go by the figure, we go by the actual lettering that they give us. B corresponds to G. Second letter, second letter. Angle B is congruent to angle G. Angle C is congruent to angle H. Third letter, angle C is congruent to angle H. That is how we get corresponding angles. Corresponding sides is almost as easy. Almost as easy. AB corresponds to FG. First two letters, first two letters. So AB corresponds to FG. BC, second two letters, corresponds to GH, second two letters. So BG is going to be proportional or ratio to GH. They correspond. And last but not least, A and C, first and last. F and H, first and last. AC corresponds to FH. So you never, ever, ever, ever go by the figure. You go by the actual similar property that they showed you. You go by the letters. Okay? Not the figure. Sir. Oh, okay. What is this? I apologize, son. This symbol means congruent. Means congruent, which is almost the same as equal. Pretty much the same as equal. Means what this is it's equal, but you're talking about similar triangles or similar figures, so they combine it together. Okay? So that means congruent. Thank you, son. Congruent. Okay, now, let's put this into play. Let's put this into action, okay? Triangle ABC is similar to FGH. I want you to find the value of FG. So the first thing I do is I'm going to go ahead and label FG with X because that's the unknown. You guys with me? Now, pay attention to this because it's really, really, really simple. Pay attention. What does FG correspond with? FG corresponds to AB. Okay. Now, what does GH correspond with? So GH corresponds to BC. Now, let's check out why I chose these. FG corresponds to AB. I have to have that because I'm trying to solve for X, right? GH corresponds to BC, so I have to use that because those are the only two values that are still complete. I cannot have gone FH to AC because AC is also a variable. We don't know what that is. So the only things that could have worked here were this setup right here. So I basically am going to do X, which corresponds to 10, equals 12, small triangle, to 16, which corresponds to 12. And now I cross multiply. 16x equals 120. Okay, divide by 16. You know me, I like to reduce things. So I'm going to divide both of these bad boys by, let's do 4, right? Let's do 4. So 4 would be 30. Oh yeah, I should have done 8. Yeah, but oh well, it is what it is. 4, and then we could go one more, divide by 2. So 15 over 2. So x equals 7.5. So this guy right here is 7.5. By simply setting up a proportion, okay, of corresponding sides to corresponding sides. Now, some people like to do it a different way. So I'm going to show you that different way so you can see it is acceptable. We're going to do it in blue. Some people do this. Okay, AB to BC, they go 10 to 16 equals Which side over here corresponds to that 10? X. So corresponding side to corresponding side. Which side over here corresponds to this 16? 12. Again, you cross multiply and you're still going to have that x equals 7.5 inches or whatever it is. Does that make sense, gentlemen? Yes? Okay, now, they're not always going to give it to you in pretty little beautiful things like this. Sometimes you got to create your own. For example, the sun's rays strike a building and a 5-foot girl at the same angle, forming two similar triangles. If the length of the building shadow is 15 feet and that of the girl is 3 feet, how tall is the building? You must draw this out. If you don't draw this out and you just try to do it in your head, the odds are that you're probably going to get it wrong. You don't have to be Picasso. I'm not going to turn this into the Dade County Youth Fair art exhibit. This is just so that you can have a sketch to understand what you did. Wait till you see how I draw. Do not laugh at me, but I'll still get it right all the time. So I have a building. Wow, that's a tough building. And I have a girl. So I like stick figures. Yay, okay. So the building is X feet high. I got the sun here, and the sun is beaming its rays at the same angle. So it's going to create a shadow. The shadow that is created from the building is 15 feet. This young lady is 5 feet tall, and the shadow that she creates with the sun is 3 feet. Before I even start to continue this, does that make sense? The rudimentary sketches that I just made. Okay, now it's easy. X to 15 must equal 5 to 3. Let's check out why. Height to shadow equals height to shadow. Remember, same unit to same unit? Same unit to same unit, always. So now let's go ahead and cross multiply, my brothers. So I've got 3x equals 75 divided by 3. X equals 25 feet tall. So the tree is the building is 25 feet tall. And that's it. It's pretty simple, no? It makes sense. Okay. We're going to do another one now. A 6-foot tall man is standing next to a flagpole. So there's another dude, and he's 6 feet tall. So he's 6 feet tall, and he's standing next to a flagpole. Okay, here's the flagpole. The man's shadow is 3.5 feet. So the sun's over here somewhere, and it's, shooting its rays, and it creates a shadow of 3.5 feet for the man. The flagpole's shadow is 17.5 feet. I want to find the height of the flagpole, X. Who can tell me the proportion to sit up here? Sir?
6 feet to 3.5 feet.
6 to 3.5, height to shadow equals? X over 17.5, height to shadow. I want you guys to realize that you could have done this as well. Height to height equals shadow to shadow. Just don't mix up where you're getting the information from. Small height to large height, small shadow to large shadow. Always keep things unit to unit. Does that make sense, my brothers? Okay? So now I'm going to go ahead and cross multiply this bad boy. Okay? It doesn't matter which setup you have, you're still going to get the same answers. So I'm going to have 6 times 17.5, which is going to give me, okay, let's just do it. 17.5 times 6, 0, 3, 5, 4, so 105. 30. Oh, okay. Yes, it is. Good job, son. So I have 105 equals 3.5x divided by 3.5 divided by 3.5. X will equal 3.5 on the outside, 105 on the inside, 1 to the right, 1 to the right. Bring that decimal up so I don't forget. That goes in 3 times, which is 105. 0, 35 goes into 0, 0 times, 30 feet. Does that make sense, gentlemen?
Yes, sir.
It's pretty good, right? Pretty easy? Pretty useful? Okay. This is, by the way, how they get measurements of really tall mountains and the Grand Canyon, for example. They sat at the bottom of the Grand Canyon and they know their own height, right? So they sit at a particular angle, which is equal to the angle of whatever rock or feature they're trying to measure. They measure their shadow. You need a partner for this. First, your partner measures your shadow. You know your height. You measure the shadow of the actual tree or rock or mountain. You measure that shadow, which is pretty easy because it's on the ground. And then their height is x. You set up a proportion. You just found the height. That's math. It's powerful. Okay. Now, scale. We have all been on road trips, and I'm sure that nowadays you guys have all used GPS. Well, back in the olden days, all right, before the days of GPS, we had to use scale. And you had to use a map and a ruler and all sorts of crazy stuff to know where you wanted to go. A scale drawing is a drawing that is similar to an actual object or place. In a scale drawing, the ratio of any length on the drawing to the actual length is always the same. This ratio is called the scale of the drawing. I put up a rudimentary little map here. Even if you're on your GPS, guys, you have what's called a scale at the bottom. It's a key. And the scale here says that for every inch on the actual drawing, it means 100 miles in real life. So every inch of drawing equals 110 real actual miles. Okay? Guess what? The scale is your fact, isn't it? So I want to find what is the actual distance from Jacksonville to Orlando. Well, we're going to set up a proportion. My fact ratio is that 1 inch equals 110 miles. That's my fact for sure, 100%. Now, what was I given here? I was given the measurement in inches. Okay? I don't know if you can see it from here, but I'm going from here, okay, here to here. All right, we've got, and actually, wait, I just messed this up. There we go. Okay, there we go. All right, so it's roughly we're talking about, it's right about 1.5, okay? So I've got 1.5 inches equals X miles. How do we solve? Cross multiply. X is going to equal 110 times 1.5. 110 times 1.5, 0, 5, 5, skip a space, 0, 1, 1, 0, 5, 6, 1, 1 decimal, 165 miles. Done. Done and done. Does that make sense, guys? Now, again, I know that you guys are saying, yeah, but I've got GPS, man. I don't need this crap. What if you run out of power one day? Then you're stuck with the map. If you don't know how to do this, you're not going to know if you have enough gas to get there, for example. Okay? So it's very useful. Very useful. Is what true? No, that's a false reading. Well, actually, no. That's about right, actually. Because from here to Orlando is about 4 hours. And then to get to Jacksonville from Orlando is about 2 hours. From here to Orlando is about 280 miles. So that's about right. Yeah, I just, made up that distance. It's about right. The key here is the procedure. Do you understand the procedure? Okay. Now, next. The distance from Jacksonville to Gainesville on a map is 0.6 inches. What is the actual distance? Well, they told us the fact was that 1 inch equals 110 miles. They gave me 0.6 inches, and I want to know how many actual miles that is. So I cross multiply. X is going to equal 110 times 0.6, 0.66, skip a space. Oh no, what am I talking about? 1 decimal, 66. 66 miles. Does it make sense? Now, let's reverse it. Let's find the scale actually. If you know that the actual distance between two cities is 250 miles, you know that the distance is 250 miles. You know that. And that the cities are 2 inches apart on a map. How can you find the scale of the map? Find a unit rate here. We know that 250 miles over 2 inches. What's the unit rate? Andy? Thank you very much, sir. Awesome. We know that the rate here basically is for every 250 miles you had 2 inches on the map. Well, that means that 125 miles would equal 1 inch. So my scale would be for every inch on the map, it corresponds to 125 miles in actual distance. Remember, why did I use the colon? Because that's another way to represent a ratio. 1 inch to 125 miles is the ratio. Sir, I just divided by 2 in this case. I found the unit rate. Remember what we said the unit rate was?
Yeah.
How many units at the bottom can go into, unit rate is when you turn a rate into a rate that has a denominator of 1. So you have to divide. Now, I would not have gone 2 divided by 250. That would have been a little bit ugly. Always go in these scales, go from large to small. Okay? Does that make sense, boys? All right, now, last one. A giant model heart on display at the Science Museum, okay, is on display at the Science Museum, sorry. The heart is the ideal size for a person who is 220 feet tall. About what size would you expect the heart of a man who is 6 feet tall to be? Now, I forgot to include one very important thing. The size of the heart. Hello? Kind of hard to do it without all the information. So, I'm not even going to try to draw a heart. All right, because it's just not going to come out good. So what I'm going to do is put human heart. Let's see. I guarantee you they're going to, oh, that's not good. That's circulation system. Yeah, I know, but I want it to be fancy. Hold on, there's a brain. There we go. There you go. Nice. Okay. See, I like to be interactive with our computer. Okay. So we have this heart, guys, and the heart, according to the information that is given to us, the heart is 14 feet long, okay, or wide. That's going to be the heart of a man that is 220 feet tall. I want to find the size of a heart for a 6-foot man. What is the fact ratio here? Come on, loud and proud, guys. Be proud. Perfect. 220 feet tall, 14-foot wide heart equals 6-foot tall man over X foot wide heart. Height to height, unit to unit, heart width to heart width, unit to unit. Does that make sense, my brothers? So now cross multiply. 220x equals 84, thank you, son, divided by 220. And x will equal, let's see, running out of time here, 0.38, roughly 0.38 inches. You could put roughly 0.4 inches because I think they tell you to round it to the nearest tenths. Okay? Does that make sense? Sir? Okay, in this case, you cannot leave it in fraction form, sir, because 84 to 20ths of an inch is very hard for me to understand. But if I say 0.38 of an inch or 0.4 of an inch, a lot easier. I'm sorry? And I'm sorry, it's not inches. It's feet. Sorry. Thank you, son. Pay attention, Mr. Morrow. Feet. Yeah, sorry. Sorry. If I wanted those feet to inches, what would I do? How do I convert them? I go large, small, small to large. Large, small, so I multiply, divide. Multiply, so I multiply by 12. So it would be 4.8 inches. Right? Okay. Does that make sense, guys? Sure? Okay. That's the lesson. Homework is valid. May God bless you and have a wonderful day.